Greetings, Joseph Kursky here with you. In this video, let's turn our map and layers into a 3D scene. It makes sense that we're analyzing, in this case, water-related data in a 3D scene. We live in a 3D world, and it makes sense that we've got 3D tools at our fingertips. And you have those tools at your fingertips inside this ArcGIS platform. So I'm going to start a 3D scene in ArcGIS Online, that's www.arcgis.com, and start a 3D scene. And in the 3D scene, I can add data. I'm going to look in my own ArcGIS Online organizational account and see what kind of data I have in there that I can use in my 3D scene. Recall in past tutorials and videos in this same series that we started with a survey. We surveyed storm drains and we crowdsourced that. We had educators and students collecting these storm drains. As you can see here, I'm adding it to my 3D scene right now. We also ran some analysis tools. We traced downstream. We created a watershed. We also added some pertinent content. Watershed boundaries, river systems. We even looked at flood potential, real-time weather, stream gauging stations, and much more. We even created this watershed, everything that flows into the point that I was out in the field at collecting data with my students, for example. Well, 2D maps are fine and they're wonderful and lots you can do with them, but 3D scenes oftentimes enhance understanding. My whole mantra with using geotechnologies is don't just do it because it exists. I know there's some value in fostering skills in geotechnologies, and there's nothing wrong with that, but you can't embrace all of the tools, but embrace them if they enhance understanding, in this case about watersheds, or whether you're teaching about natural hazards or population change or energy or water or human health or social inequities or whatever you're teaching about. Use 3D scenes to perhaps enhance the understanding. And remember, 3D scenes are not just for physical geography related data. You can extrude population data, attitude data, business data, and others into a 3D environment. So it's not just for physical geography / environmental science / geology. It can be used for other things. So I've got my two traces from the points that I've collected data, or maybe I'm just interested in those points. I've traced downstream. One trace goes to Lake Ontario, and the other stream trace goes all the way down to the Allegheny, to the Ohio, to the Mississippi, to the Gulf of Mexico. And I demonstrated that in a prior video. And now I'm tilting my 3D scene, and I can also adjust the sun for the time of day so I can see basically what this data would look like, what this landscape would look like on today's date in early August 2021 at different times of day. And of course, you can teach about seasons and all kinds of things with that simple tool, that daylight tool. I can also change the base map, of course, to a satellite image so I can really zoom in on these valleys where these rivers run. And if students have trouble figuring out what a watershed is and why these traces flow the way they do, I think that these 3D scenes with the satellite imagery and also the terrain with labels really enhances their understanding. Then, of course, if you wanted to go at the extra distance and do some further 3D studies, we have Arcgis Pro, and you have Arcgis Pro at your fingertips also. It's a desktop connected to the cloud digital geographic information systems environment. But I'm just using ArcGIS Online right now, and I can see even with that, I can start zooming in on these different stream traces and looking at the valley. So it makes sense that this trace that I was looking at here in southwestern New York flows northeast before it bends around to the southwest. It makes sense looking at the valleys and the configuration of the valleys the way they are. And of course, there's all kinds of things you can do in addition to enhance this. You could drape on the superficial geology layer or the subsurface geology and talk about why those valleys are carved the way they are. Certain rock strata are more easily erodible than others, and so on. So that's why you've got those wonderful valleys. Oh, it's just beautiful, just beautiful. Wonderful to be able to do this at your fingertips. So it's the 3D scene viewer inside ArcGIS Online, and you've got measure tools and some other things, the ability to add data, the ability to zoom pan and visualize the landscape in engaging ways. So there's our original stream gauges there in Buffalo with our trace to the north side of Buffalo that actually flows over Niagara Falls. And since we've got a 3D scene at our fingertips, you know what I'm going to do next, right? I'm going to change the base map to perhaps a satellite image and take a look at where these particular storm drains drain into. And since we're not too far right here from one of the world's most awesome waterfalls, Niagara Falls, this will be a very engaging part of our investigation. So let's just do that. I've got a base map tool there on the right side in the 3D scenes, and I can go ahead and change it to imagery hybrid and then take a look at the upstream and downstream, the physical environment, the cultural environment. Let's pan a little bit out to the northwest of the storm drains because I want to check out Niagara Falls, and there we've got it in a satellite image that's draped on top of the 3D scene. So we're going to see some differences. If we were flying over this in a drone or in an airplane or a hot air balloon or something like that, this would look slightly different, right? You're going to have some resolution issues, and you can see there that it's looking not exactly like it would look if I was, again, flying over this, but the ability to do this in these tools, you can see that when the observation platform looks like it's draped and curved. So talk about some resolution issues and imperfections of maps and data layers like this, but still, that's a nice teachable moment here. But flowing over Niagara Falls from our stream trace that we conducted in the last video with the analysis tools, it's just a trace downstream tool that you have available in ArcGIS Online at your fingertips, and it traced where water goes from that certain point on the landscape that I dropped the pin on in ArcGIS Online. And then flowing out into Lake Ontario, how does it do that? And you can see a little bit of imperfection here with the stream trace, not exactly drawing. It's a little bit of a coarser resolution. Obviously, it's the water's not going to flow over the land here. So again, another moment of instruction about maps and scale and so on. I've also got another moment of instruction here, and that is the satellite image has a bit of a lighter tone right there in the Niagara River, and I suspect that's not anything related to water quality or the type of superficial or subsurface rocks underneath there. I have a feeling it's an artifact in the imagery itself. So again, talking about the use and also the limitations of imagery. We can also, of course, save this scene, put some metadata in there. You can share it with just your community, just your students, just your fellow faculty members, or with the whole world if you want people to investigate and engage with the content that you've created. That's what modern GIS is all about, is engaging people and building a community and getting people to care about real issues, for example, water, watersheds, and so on. I'm navigating back down to Buffalo now, and I'm looking at my storm drains that I've collected with teachers in this case, but it could just as easily be with students. Saving the scene. Okay, excellent. Now let's talk about a couple of other things that you have available to you in the 3D scene. You can capture slides, and I'll demonstrate why this could be a powerful instructional technique. Let's say you're teaching about famous and most pertinent landforms around the Earth's surface: lava beds, trellis drainage, dendritic drainage, deltaic formations. The list goes on. You can create a separate slide for each one of those alluvial fans, etc., in your landforms. In this case, I'm going to have a couple of slides with different locations where the water actually traced down from that point northwest of Buffalo. I'm creating 3 different slides, if you will, although slides is not a perfect term for this because they're engaging content. It's dynamic content with ArcGIS Online and these data layers as services, the imagery, the vector layers, the points, lines, and polygons, etc. So now I've got 3 different slides, if you will, and I can navigate as I'm doing at the bottom of this 3D scene right here, and I can see that with that technique, I can quickly have a focus of, okay, Buffalo, Niagara Falls, and then finally Lake Ontario. Can I customize this a bit more? Let's say I want that final one to be a terrain with labels base and not the satellite image base. Can I change that? Sure, I can. I can update that slide, or I can duplicate that slide and get rid of the original. Either way, but on that last slide, I'm going to change the base map to terrain with labels, as you see me doing here. And so that's changing my Lake Ontario, again, dynamic slide, if you will. So let's test that out now. Capture that slide and get rid of that original one. Lake Ontario terrain, we'll call it. And so now I've got 3 slides now, Buffalo with a satellite image base with my storm drains, Niagara Falls showing my stream trace, and the final, not quite the final, right? The place where the water flows out into Lake Ontario here. So I've got several layers in my 3D scene. I've got several slides now in my 3D scene. I've demonstrated how to change the sunlight angle, changing the base map, adding layers. Lots at your fingertips. Let's reorient ourselves so north is at the top, but certainly no requirement to do that. And let's go ahead and save this, and then of course we could share it with others. Fascinating and powerful to be able to do this. I encourage you to engage with these tools to foster community connection, to foster understanding our world, local to global scale, in this case about watersheds, but it could be much, much more depending on where you're teaching and in what level. Primary, secondary, community, technical, tribal college, university, lifelong learning, libraries, museums. Thanks for being here. Take care. Bye.